Bismillahirrahmanirrahim. Assalamu alaikum students. Today we will discuss the numerical problems of chapter number 8. Starting from problem number 2, consider a steel bar of length 1.5 meter. तो एक स्टील बार है जिसकी लेंथ 1.5 मीटर है, सो L नॉट इज 1.5 मीटर at 10 डिग्री सेल्सियस. सो इनिशियल टेम्परेचर उसे T नॉट से रिप्रेजेंट करेंगे. इट्स वैल्यू इज 10 डिग्री सेल्सियस. इट इज हीटेड, आपने उसे हीट किया टू रेज द टेम्परेचर टू 100 डिग्री सेल्सियस. सो फाइनल टेम्परेचर और T राइज इज 100 डिग्री सेल्सियस. फाइंड द इंक्रीज इन लेंथ, तो आपने उसकी चेंज इन लेंथ कैलकुलेट करनी है या डेल्टा एल कैलकुलेट करना है, and final length भी calculate करनी है. So L final at 100 degrees Celsius if the coefficient of linear thermal expansion of steel is 1.2 into 10 raised power minus 5 per Kelvin. Okay, so solution is first of all we will calculate the value of delta T. So delta T is final temperature minus initial temperature. Here final temperature is T rise, initial temperature is T naught. So value would be 100 degrees Celsius minus 10 degrees Celsius. So answer would be 90 degrees Celsius. As we know that delta L is equals to L naught alpha delta T. So placing the values, delta L is equals to L naught is 1.5, alpha is 1.2 into 10 raised power minus 5 per degree Celsius, and delta T is 90 degrees Celsius. So answer would be 0.00162 meters. We can write it in this way, that 1.62 into 10 raised to power minus 3 meters. In the next part, we need to calculate its final length at 100 degrees Celsius. So we know that total final length is equals to original length plus change in length. Okay, so original length 1.5 और change in length अभी हमने calculate की. So answer would be 1.50 in 1.50162 meters. Moving towards question number 3, a solid cube of side length 10 centimeter. So आप लोगों के पास एक क्यूब है जिसकी सब साइड्स इक्वल होती हैं, is at 25 degree Celsius. So length of the cube is L naught, that is 10 centimeter. Its initial temperature T naught is 25 degree Celsius. What will be increase in its volume? So you need to calculate delta V at 125 degree Celsius. So T rises 125 degree Celsius if its coefficient of linear thermal expansion. So ये आपने एक बात याद रखनी है कि यहाँ पे आपको कैलकुलेट तो डेल्टा V करना है, लेकिन बीटा की वैल्यू नहीं बल्कि आपको अल्फा की वैल्यू गिवन है, बिकॉज linear thermal expansion is represented by alpha and its value is 9 into 10 raised power minus 6 per Kelvin. Okay, volume is A multiplied by B multiplied by C. Since ये क्यूब है तो इसकी सब साइड्स इक्वल होती हैं. So 10 centimeter multiplied by 10 centimeter multiplied by 10 centimeter. So its initial volume would be 1000 centimeter cube. As we know that delta V is equals to beta V naught delta T, and again relation between beta and alpha is that beta is equals to 3 alpha. And delta T would be final temperature minus initial temperature, so T rise minus T naught, so delta T would be 100 in this case. So delta V is equals to beta is 3 alpha, V naught as it is, and delta T as it is. So placing the values 3, alpha is 9 into 10 raised power minus 6, V naught is 1000 centimeter cube, and delta T is 100 in this case. So answer would be 2.7 सेंटीमीटर क्यूब. सो यूनिट्स का आपने ध्यान रखना है, दैट यूनिट वुड बी सेंटीमीटर क्यूब. ये पर डिग्री सेल्सियस, ये डिग्री सेल्सियस से कैंसिल हो जाएगा. सो आंसर वुड बी इन सेंटीमीटर क्यूब्स. नेक्स्ट क्वेश्चन नंबर 4, फाइंड द अमाउंट ऑफ हीट. सो यू नीड टू कैलकुलेट द वैल्यू ऑफ Q given to 25 kilogram of water. So mass of water is given to you, that is 25 kilogram. To increase its temperature, आपने उसका temperature increase किया by 50 degree Celsius. So initial temperature let's say is 0 degree Celsius. Final temperature is 50 degree Celsius. So delta T would be 50 degree minus 0 degree. As we know that C or specific heat is equals to Q divided by M delta T. Since we need to calculate the value of Q, so M और delta T equal के दूसरी साइड पे जाके C से multiply हो जाएंगे. So Q का फॉर्मूला बन जाएगा Q is equals to CM delta T. अगर आप इसमें वैल्यू सब्स्टिट्यूट करें, C for water is known to you, that is it is 4190 joule per kg per Kelvin. वैल्यू सब्स्टिट्यूट करेंगे, so your answer would be 5237500, or you can write it as 5.2 into 10 raised to power 6 joules. Heat क्योंकि एनर्जी है, so its unit would be joule. Question number 5. How much heat is required? So you need to calculate the total value of heat. Again, Q calculate करना है. Is required to change 15 kilogram of ice. So mass of ice is 15 kilogram into water. So now you need to change the ice into water at its melting point. So you will be using here the latent heat of fusion because phase change आ रहा है. तो ये बात आपने याद रखनी है कि जब भी phase change होगा तो फॉर्मूला Q is equals to MLF और MLV यूज होगा, और जब भी phase change नहीं होगा, सिर्फ टेम्परेचर किसी भी मटेरियल का चेंज होगा, तो आपने Q is equals to MC delta T ये वाला फॉर्मूला यूज करना है. Okay, so here in this case phase is being changed, so Q is equals to M into LF. M is given to you 15 kg, LF is again 3.3 into 10 to the power 5 joules per kg. So answer of Q would be 4.9 into 10 to the power 6 joules. Question number 6. How much heat is required? So you need to calculate the Q to change 7 kilogram of water. Mass of ice is again given to you, that is 7 kilogram, into steam. So you need to convert it again into steam. So phase change is again involved at its boiling point. So latent heat of vaporization is 2.26 into 10 to the power 6 joules per kg. Formula that you will be using is Q is equals to MLV. Putting the values, you will get the answer that Q is equals to 1.6 into 10 to the power 7 joules. Thank you so much for your time, and if you have any query, please do let me know in the comment section. Thank you so much. Allah Hafiz.